Good afternoon, grade 10s, 11s. So since you guys are writing mathematics this week on functions, and we didn't get a lot of time to go through it in class, the purpose of this video is just to revise some of the key concepts that you might, or that you're gonna get tested on. Now, before we go through it, please remember that whenever we talk about an x-intercept, okay, this is where our function or our graph cuts through a x-axis. So in other words, your y value there will always be 0. When we talk about a y-intercept, then that is where your function cuts through the y-axis, and at a y-intercept your x value is always 0. And then when we talk about a point of intersection, this is essentially where your two graphs are equal, or where they are cutting each other, and in those two cases, or in that case, we know that the two functions must be equal. Now, out of the functions that you are going to be tested on in the paper this term, or yeah, the June paper this term, there is two functions that we focus on: the straight line and the parabola. Now, when it comes to the straight line, okay, the y formula will always be y equals to mx plus c, or it will have some form like this. In other words, the moment you see something timesing with an x, without the x having squares or anything weird, you know that it's a straight line. So this represents the general formula for a straight line. Now, from grade, there's a few basic things you should know from analytical, such as the c value always gives you the y-intercept. Okay, in other words, where it cuts the x-axis, the y-axis, and in that case, your coordinate will always be 0 and just whatever your c value is. We should also know that the c value essentially tells you with how many units the function either moved up or with how many units it moved down. So just from the formula, if you know the c value, or if you want to find the c value, you should know that it relates to the y-intercept. Furthermore, the m, which is the gradient, just refers to the inclination, or how skewed the line is. And typically your gradient can tell you one of four things. If your gradient is positive, you know that you should have an increasing straight line, meaning as you read the graph from left to right, it should go up. So if you read the graph from left to right and the function goes up, so from left to right, but the function goes up, then you know it's increasing. Now, your gradient can also tell you that the function is decreasing, and in this case, if you read the graph from left to right and it goes down, then it is decreasing. Then the gradient can also, well, if there's no gradient, that essentially tells you that your line is flatlining, so it's just a horizontal line. So there's nothing weird in this case, and normally your equation would then just be y equals to whatever your c value is. And then lastly, if the gradient is undefined, then we should know that we just have a vertical line. And normally in the case of a vertical line, the equation would then just be x equals to whatever the value is where it cuts the x-intercept. So out of the two, the straight line is the easier one that we've got used to, and this is all things that we know from analytical geometry. The parabola, our next function, is where things actually start getting a little bit more interesting. Okay, now whenever I want you to get into the pattern of wherever you see a x to the power of 2, you should immediately think parabola. So x to the power of 2, that's normally like your identification for a parabola. Now, if you take a look at the general equation of a parabola, there's a few things we can determine from the formula itself. Starting at the a value, you have two options. Either your a value is positive, okay, or it is negative. So a is either going to be bigger than 0 or a is going to be smaller than 0. If you have a value that is bigger than 0, we would normally then have a smiley face, okay, with your turning point in, well, at least in grade 10, being on the y axis, on the y intercept. And then if it is a negative, then your function will tend to be a frowny face, okay, or a sad face. Now, what's important to note here is that both these functions can be seen as increasing and decreasing for some values. Now, what I mean with that is we know that our turning point in grade 10 was as x equals to 0. And if you take a look at this left one where it's a smiley, if you read the graph from left to right, it starts being decreasing first. Then once it gets to the turning point, then it becomes increasing. In other words, for your values smaller than 0, it was decreasing. And for your values bigger than 0, your x values bigger than 0, it was increasing. Now, typically for a negative graph or a sad face, that pattern would just be the opposite. So where x is smaller than 0, it would be increasing. And where x is bigger than 0, it would be decreasing. Okay, now that is all that you can tell from the a. Now, if you take a look at the c value then, this typically then tells you where you find the y-intercept. And the y-intercept will always have a coordinate of 0, c. In other words, let's say your c value was 2, then your y-intercept would be at 0, 2. If your c value was negative 3, then your y-intercept would be at 0, minus 3, for instance. So it all depends on your c value. Now, grade 10 as well, the c value still tells you with how many units the function moved up or down. And it also gives us the coordinate for the turning point. Please do note, however, in grade 11, once we get a little bit more in depth into functions, this is going to change slightly, but for now, the turning point is at 0, c. And that's basically the basic properties that you would need if you want to continue with functions, or if you want to work through the functions needed. Now, typically one of the examples where or questions we'll ask you in a question paper is I'm going to give you an equation for a function, and then from there you should sketch it. Normally stepwise, but they tend to follow the same steps. Now, typically when sketching a function, there's two methods you can use. Either what we refer to as the table method. Now, this is what we use at the start of grade 10, or you'll use the intercept method, which is normally what we'll use more towards the end of grade 10. Now, typically we'll be explicit. We'll ask you to use the table method if we want to use the table method. Otherwise, you're going to use the intercept method. Now, basically what the table method entails is you are going to go and you're going to say, okay, I'm going to pick a few x values. I'm going to draw a little table. I'm going to pick a few x values. In this case, it's always safest to use -2, -1, 0, 1, and 2. And then you're going to take those x values and substitute them into the equation that was given. So in other words, you're going to say f of minus 2, first value I'm substituting in is x. So everywhere where I see a x, I replace with minus 2. So it becomes minus 2, open bracket, minus 2 squared minus 4, which is then going to give you 4 minus 4, which is then going to give you 0. Okay, so when your x value is minus 2, your y value is 0. Then you do the same for minus 1, which in this case would then be minus 1, which is minus 1 squared, minus 4, which is going to give you minus 3. And you don't need to show these calculations. You can just complete the table. But typically, this is what you would do. You're just substituting in. Then you get your values. From there, you're going to use these values to sketch the function that you have. And to do this, you need to draw a Cartesian plane. Now, normally you would use, this needs to be on scale, and you're going to use a ruler. So you're going to have your Cartesian plane. Remember to indicate your x value, your y value. You're going to have equal intervals. Now in this case, my biggest x value I'm using is 2. So I'm only going to make my x-axis up to 3. My smallest x value I'm using is minus 3. So I'm only going to, minus 2. So I'm only going to go up to minus 3. Y values, the biggest value I have is, well, 0 in this case. So I'm going to go up to 2 on my y-axis. And in my y values, the smallest one is minus 4. So I'm going to go all the way down to minus 4. From there, I'm going to plot my points. So I'm going to start at minus 2, 0. So where my x value is minus 2, my y value is 0. That we know is an x-intercept. Then minus 1, minus 3. That is going to be somewhere down there. Then 0 minus 4, that is going to be, since our x value is 0, we know that's a y-intercept. Then we have 1 minus 3, that's going to be somewhere around there. And then 2 and 0, that's another x-intercept. Now from the function and from our dots that we've plotted, this is clear that this is going to be a parabola. So now, to the best of our abilities, we try to link these dots using the parabola shape. Please, this must be curved lines. Okay. In other words, I do not want to see any straight lines linking these dots. Okay. So to the best of your ability, use curved lines to sketch the function. You don't get marks for how or for how accurate you have the actual shape, or well, you do get marks for the shape, but you're not going to get mark for how perfect of a parabola it is. It must just be clear that it's a parabola at the end of the day. And that would be your graph using the table method. Now, the intercept method only takes key aspects and uses that to sketch. So in other words, when you are using the intercept method, you're going to have to determine the x-intercept, the y-intercept, and in the case of the parabola, you will need to find the turning point. Now, if we start off with the x-intercept, immediately we know the y value is 0. So we're going to take that, substitute it into our equation. So then we know that f of x is a fancy way of talking about y. So it becomes 0 equals to x squared minus 4. Now it becomes a quadratic equation, so that we need to solve for x. So we can transpose the 4. It becomes positive, so 4 equals to x squared. You take the square root on both sides, and then you get an answer of plus minus 2 equals to x squared. So meaning your one coordinate is where 2, 0, and the other one is at minus 2, 0. Now it's at this point where you could have also, instead of um, solving x the way we did, you could have used difference of two squares, and then your bracket would have been x minus 2 x plus 2 equals to 0, and then it would have given you the same values. But so far with the intercept method, we found the x-intercept. Next up, we then find the y-intercept, and we know that this is where your x value is 0. So that basically just means that your y-intercept will be, well, you can calculate this, and then it would be y equals to 0 squared minus 4. Thus y is equal to minus 4. Or, since we know that um, the value here, this plus or the minus 4, tells you where the y-intercept is, you could have immediately just said the coordinate is 0, minus 4. Similarly, we know that the turning point will be on the y-intercept, so the turning point is also at 0, minus 4. Now, the key difference between the intercept method and table method typically is we don't worry about whether or not it's on scale. So you're going to quickly draw a Cartesian plane. This is my x, this is my y. And then you're just going to plot these main points that you calculated. So in other words, minus 2, 2, and then the turning point, which was minus 4. We know from the equation this is a happy parabola. So now we just connect those three dots, those main key points, with the shape of a parabola. And there you go, you've sketched your function. Now, along with sketching a graph, I can also ask you to interpret a graph. So what that basically means is I'm going to give you a sketch with the equations, a bit of few unknowns, for instance, and then I'm going to ask you to, hey, help or find a few points or determine a few things for me. Now, if we take a look at this, what I always like to start with is, before I consider the questions, I try to make sure what my equations are telling me. So for instance, if we take a look at f of x, I see a x squared there. So immediately I know this is going to be a parabola. For g of x, I see something times x. The x doesn't have any weird exponents or so. So that tells me this is a straight line. So if I consider my sketch then, that would mean f of x is this parabola, this frowny parabola. And then the straight line, this negative x, is going to be this decreasing straight line. Now, once I understand which formula goes with what function, then I can start considering the questions. Now, the first question I can ask you in this case is to maybe determine the coordinates of A and B. Now, if I consider what A and B are, without without me telling you that this is it, if you take a look at A and B, you'll see that they are where the parabola cuts through your x-axis. And because that is why it cuts through your x-axis, you immediately know that these are x-intercepts. And because they're x-intercepts, immediately you need to know that your y value is going to be 0. So this means you're going to take your formula for the parabola, and wherever you see f of x, that's your y, you're going to make it a 0, and you're going to say 0 equals to negative x squared plus 4. And then you're simply just going to solve for x. Now in this case, you're going to transpose the 4, so it becomes negative 4 equals to negative x squared. Divide both sides with a negative 1 so that we can get the x squared positive. And then from there, to get rid of the square, we're going to take the square root on both sides, which tells you that x needs to be plus minus 2. Now that means your one coordinate is going to be minus 2, 0, and your other coordinate is going to be 2, 0. And now you simply just take these answers back to your sketch and compare it. If you take a look, A is on the negative side of the x-axis and B is on the positive side of the x-axis. So that means that wherever the coordinate that had a negative answer for x, that is going to be the coordinate of A, and then the whichever has the positive coordinate is going to be the x or the coordinate for B. Now, along with this, a next question we can then ask you is to determine the y-intercepts, or in this case, not y-intercepts, to determine the coordinates of, well, it says there F, and then I did not indicate it, but F and G. Now, by taking a look at your sketch or on your sketch, F and G is where your two functions intersect or cuts through the y-axis. That means that makes them y-intercepts. And that's essentially where your x values would be 0. Now also we know that these values that we're adding to the end of our functions, this plus 4 and the plus 2, those tell us where the y-intercepts of the functions would be. So f is the y-intercept of the straight line, meaning its coordinate is going to be 0 and it's going to be 0 and 0 plus 2, and then for your coordinate of G, which is the y-intercept of the parabola, that coordinate is just going to be 0, 4. Now, if you are not comfortable by just reading off the y-intercepts from the graphs, taking use of the formulas, what you could do as well is, for example, and I'm going to do the coordinates of G using calculations, you could say, okay, but it's the y-intercept, therefore you know that the x values, therefore you know that the x value must be 0, and you simply substitute that into your equation. So the formula for f of x is going to be y equals to negative x squared plus 4. You know your x value is 0, so y is just minus 0 squared plus 4, which would give you 4. And then from there you just write down your coordinate. Now, that is one of the questions we could ask you. Another question we can ask you is to determine the coordinates of E and D. Now, the question is to determine the coordinates of E and D, and where you start is go to your graph and identify those points. So E is up there, while D is down here. And what should be significant about these 2 points, that's essentially where the two graphs are cutting each other or intersecting with one another. So that means these are points of intersections. And immediately once you have identified that they're points of intersections, you should note that that means the two functions will be equal. So that means we're going to start off by equaling these two graphs to one another. And then we're going to start by solving for x. So in this case, this will be a quadratic. So everything to one side, so that we transpose everything to one side to get it equal to 0. So that's going to be x squared minus x, and then minus, or the 4 comes over, becomes a minus 4. So 2 minus 4 gives you minus 2. From there you realize, this is a trinomial, so I factorize it. So this becomes x minus 2, x equals, or not equals to, x plus 1. And from there you can then calculate your x values. So that means your 1x value is at 2, or your other one is at minus 1. Just get that properly spaced. Okay. But now this is not where we end, because this is only the x values, and we need to find the y values as well. Now for coordinate E, okay, we know if we compare the two values we got, that would be the negative 1. Now we just take that value and we substitute it into any one of the two equations. Now I'm substituting it into g of x. Why? Because g of x just has less squares and things that I need to worry about. So I'm going to substitute it into g of x. So that means my y value is going to be equal to 1 minus 1 plus 2, which would then just give me 3. So that means my coordinate for E is going to be minus 1, 3. If I do the same for the plus, or for the plus 2, if we do the same for the x value of 2 that we got, and we substitute that into g of x to get the coordinate of D, we would say that y is equal to negative, open bracket 2, close bracket 2 plus 2, which would give us 0. So it means the coordinate of D would then just be simply 2, 0. And that was it. Since they were points of intersections, you equal the functions and you get the x values, substitute them in, get the y values. Now another question I can give you is a question that I ask you to determine lengths. So the first thing that the length of HA. Now the first thing that I want you to consider here is the length of the line that you are calculating. Is it a diagonal line? Is it a vertical line? Or is it a horizontal line? Okay, because when it comes to functions, this can be simplified into 3 very easy situations. If it's a diagonal line, then you need to use the distance formula from analytical, or Pythagoras, but distance formula would be one of the go-tos there. If it's a vertical line, meaning a line that just goes up or down, then you're going to take the y value at the top, and you're simply just going to subtract the y value at the bottom. And if it's a horizontal line, a line that goes left to right, then you're going to take the x value on the right, and you're going to subtract the x value on the left. And that would then give you your distances. Now, if we consider h of a in this case, it would be this red line here that they want us to find. And if you take a look at it, that's going to be a vertical line. So in other words, since it's a vertical line, you need to take your y value at the top and subtract your y value at the bottom. So meaning the distance for HA would be these two y values. Now, since we don't know these y values, we then need to get a little bit creative. And instead of saying y top minus y bottom, we're going to take the function that's at the top, which is g of x, which remember is just a fancy way of writing y, and we're going to subtract the bottom function at those for those two coordinates. The function that's the lowest, which in this case is the f of x, the parabola. Now from there, we're going to substitute in, and we know that g of x is minus x plus 2, f of x is minus x squared plus 4. And now you simplify. And this simplifies to x squared minus x. And then the minus times the positive 4 gives us negative 4. Or subtracted from the 2 gives us minus 2. So now you have this formula that can help you determine the length. Now if we can figure out what the x value is, then we can substitute it in and we can find the length. And this is where our coordinate for a comes in. Because since we know, this question would normally say the line is parallel to the y-axis. Since we know that if the x value down here for a is minus 2, the x value at the top for h will also be minus 2. So from there we substitute in our x value. So our length of HA is negative 2 squared minus 2 minus 2, and that's going to give us 4 plus 2 minus 2, which is just 4. So the length of HA in this case would have been 4. Now, other questions I can ask you now is, for instance, questions that use the calculations you've already done. So for instance, if I consider the next question, I can ask you question 6. I can ask you for which values of x is f of x increasing and decreasing. Now from there, we need to go back to our graph and consider what our graphs tells us. Now normally we're going to start at our turning point, which in this case is G. And we know that our turning point lies on the point where x is 0. Now we go from left to right and we're going to read our graph. As we move from left to right, we should notice that our graph is going up. So that means since your graph is going up, it is going to be increasing. So we can say that for all of our values of x smaller than 0, just before the turning point, your function is increasing in this case. And then once you reach the turning point, then you'll notice the graph starts going down. And that would be for all of your x values bigger than 0. So in this case then, I can ask you, or then you say for all of your x values bigger than 0, the function is decreasing. Now, another question I can also ask you is to write down the axis of symmetry of the function f of x, which is the parabola. And we should know from our theory that at least in grade 10, this will always be where x is equal to 0. Because it's always going to be the axis of symmetry in grade 10 level at least. Other questions I can also ask you is to write down the domain. Now, the domain we should know refers to, we should know that the domain refers to all of the x values that your graph uses. Now, for the straight line and the parabola, the domain will always be an element of all the real numbers. So you can just say x is an element of the real numbers, or you can write down x is an element of minus infinity to infinity. Um, well, and also remember that this will depend on what we, if we give you some restrictions, but typically we won't give you any restrictions. So the domain for the parabola and the straight line would just x be element of all the real numbers. Alternatively, I can also ask you to write down the range. Now, the range has to do with all the y values. So basically what I'm asking you is, what y values are we using for, let me just specify, in this case, for f of x, the parabola. Now, first thing you do here, you go to the turning point and you figure out, is this a minimum or a maximum? So if it's our highest point, then it's a maximum. If it's the lowest point, then it's a minimum. In this case, it is the maximum. So all of your y values need to be below that y value. So immediately you're going to say y, and since it needs to be below that value, then you would say it needs to be smaller than or equal to whatever the value at your the y value at your turning point was, which in this case we calculated it before, should be 4. So your y value should be smaller than or equal to 4. Alternatively, if it was a sad or a happy face, then it would be a minimum. So you would say it needs to be bigger than your y value. And with that, that should give you a quick rundown of all the basics you'll need for functions.